Hi, I'm Rosemary, and this is my project, Expanding the Network, Modeling Relationships in the 1911 Charlotte, North Carolina Directory in Neo4j. Just to give some brief overview of the project, I wanted to explore how the use of different data models and structures can allow us to explore different aspects of a historical data set. In this case, that was the 1911 City Directory for Charlotte, North Carolina, which has been digitized and is available through the Internet Archive. Using this data set, I wanted to experiment with the flexibility of graph databases like Neo4j, since I thought it might be, a little easier to manipulate and remodel than traditional relational databases. And I wanted to see how radically I could change the result graph while making relatively few changes to the arrangement of the source data. Instead, I wanted to focus on changing how I defined certain nodes and drew certain relationships. This project works with a smaller subset of the data to serve as proof of concept and takes a design-oriented approach, because I was more interested in experimenting with how we can push and pull this data around rather than asking specific historical questions. Just to give a little bit more background on the source data, the Charlotte City Directory is a highly structured data set with information about people and places, so individuals' names, races, occupations, and residences, which provides a precise snapshot of city demographics at this moment in time. And although it's organized to focus on individual records, the amount of information provided about those individuals makes it a good ground for relationship analysis. And this way we can start to ask more questions about the relationships between individuals and between the attributes associated with them. Here are some of the computational thinking practices that I believe apply to this project. You can read more about them at cases.umga.edu. And I used several different tools here, which I will discuss each in turn as they come up in the project. So let's talk about data modeling. This project grew out of an assignment that I had done for the INST 742 course earlier in the semester. And for that assignment, the goal was to use the database in its in its original structure for creating a simple graph database and then query that database to see if you could pull out any interesting insights. And I found over the course of completing this assignment that I couldn't I wasn't finding satisfactory results to my queries because of the way certain relationships were represented, specifically the representation of marriage relationships, residences, and residence types had been flattened a bit and lacked some complexity. And so you can see these two result graphs here, and we'll return to those queries later on in the discussion. To discuss some of the downsides of the previous data model, the data model originally used for the Neo4j assignment was almost too faithful to the structure of the original source data to the point where it didn't really provide an accurate representation of the relationships in the directory. And so I reverse engineered a flowchart to sort of represent a conceptual model of that database and use this to identify the aspects I wanted to modify. I use the arrow.apps tool created by Neo4j to illustrate this model. It's a little bit cleaner than just drawing it out on some scrap paper. But you can see that spouses are not given their own node and are instead listed as a property of the marital status node, which felt kind of counterintuitive to me. And also address is listed as a property of a person instead of being related to the dwelling type, which also didn't seem quite right to me. And those were things that I wanted to try and change. So for my new data model, I sketched out a lot of possible versions, keeping in mind the kinds of queries I hope to be able to answer to guide this design process. And when I had settled on a version that seemed the most promising, I created it once again in arrows.app to get this cleaner representation. It's a little bit bigger. It doesn't want to fit all the way on here. But as you can see, sort of everything radiates out from the person node in the center, which has as its properties only the person's name. Every other attribute is separated out into a different node because that makes it easier to search on. The spouse node is labeled as spouse instead of person, which it became in later iterations of the database because this was just sort of part of the brainstorming process and to give me a sense of how I wanted it to look. If I were to reverse engineer the final product database into a flowchart, it would look a little bit different than this. Yeah. And so after doing that, I needed to make some modifications to the CSV. I used the filtering and conditional formatting capabilities in Excel to streamline the manipulation process, and then converted it back into a CSV later on. The biggest change was the creation of separate rows or records for the people listed only as spouses in the original data set, so that they would be listed as distinct individuals. And then I filled that in with as much information as I had about these individuals. I felt safe in assuming their address and marital status, but not in their race, just because I didn't actually have any, concrete information about that and didn't want to extrapolate too much. And there's a link to the finished CSV. So moving on, we'll talk a little bit about the actual database creation process now. So something that is a little bit different about working in Neo4j as opposed to relational database management systems like MySQL is that you have to write the code that creates the database yourself. At least in the way I was working with it, I couldn't find a way to sort of uh, create a diagram and forward engineer the sort of physical database. But while writing the script myself is a little bit more labor intensive, it does give you a higher degree of control over the creation of the database and more ability to fine tune things. So here I've included the create script used for the graph database in the original assignment. And then this is the modified version that I created to create the database used in this project. I did the load in 2 stages. The first to create all of the nodes and some of the more simple relationships, and then a second load script to create the person-to-person marriage relationships, since the process of creating those was a little bit less intuitive than I had hoped. I relied a lot on the Neo4j documentation and the brilliant insights of the folks over on Stack Overflow to help me figure out a way to do this. I am not particularly fluent in Cypher, I would say, so I'm sure there are more, efficient or more elegant solutions out there, but this was just sort of a patchwork solution to get the job done. One of the big realizations I had was that a unique identifier was going to be necessary in order to clearly define relationships, hence the person ID and married to columns that you can see in the CSV that I modified. And these function a lot like primary key and foreign key relationships in SQL, and so that connection made it all make a little bit more sense to me. And so the process of executing the script and ingesting the data was a lot of back and forth troubleshooting, because every time I wrote something new, I had to test it and make sure it worked, figure out what didn't work, go back, try again, rinse and repeat. I've included a couple samples of my early test code in here where I was trying to see if I could get Neo4j to build the relationships I wanted without having to make too many modifications to the CSV, which didn't end up working. And so here's what the full graph with all 48 individual records and their associated information turns out like. And since this is a smaller data set, you can, pick out some interesting relationships just from looking at this full graph, but you get a little bit more out of it when you start querying, which we'll talk about now. So I ran 2 sets of sample queries to explore the data model. The first was queries that I ran in the original assignment that I wanted to try again with the new data model, and new queries created for the project specifically, whereas the second set. So some of the old queries I reran included one that returns a person, their marital status, and their dwelling type. And in this version of the database, returns their address as well. And so this graph is a little bit more spaced out and easier to visually dissect than the one we saw earlier. And it also gives us a more accurate sense of the number of individuals living in each type of dwelling, because spouses appear as distinct nodes. And the second query I ran, I investigated relationships between marital status and race. This one didn't have quite as dramatic of a change because, I didn't assume the race of any spouses, and so they're not included in this graph. However, it does still have a more streamlined appearance because the person nodes are connected to the marital status nodes and not splintered out into the combined marital status spouse nodes that we saw before. And so these are some of the new queries I created to test this one, to test this data model. This one isn't particularly exciting. It's just all person-to-person relationships within the database. But for me, it was super duper exciting to be able to generate this at all, because it meant that not only did my data model work, I was able to execute it correctly in Neo4j. So I'm very attached to this one. And then I also ran a query looking at jobs held by married people. And this one I think is kind of interesting because I am not displaying the marital status nodes in the output graph. So I just have the sort of ring of wives whose job is listed as null, and then the outer ring of husbands and their jobs. So that I think is really interesting. And this one is a variation on one of the earlier queries where it's just person and address and dwelling type. And I think this one is interesting because it gives us sort of a tidy depiction of each household unit in a way. And so I'd be interested to see this query in particular with a larger data set. Future work on this project could definitely include expansion and scalability. It would definitely be possible to expand this project to encompass larger versions of this data set, either the 160 record set or the 16,000 record set. However, scalability might be difficult because of the way that I had to do the data manipulation for this project. It had to be done manually in Excel because I was creating a large number of new rows, and tools like OpenRefine are not particularly well suited to that. I would certainly be interested in exploring automated workarounds for this issue, but that just wasn't feasible within the time constraints of this particular iteration of the project. And then I think as a proof of concept, this project and its resultant products provide very compelling evidence that adjusting data models can open up historical data sets in new ways. Compared to the previous model, this data model allows for queries that dig a little bit deeper into the data set and give us a more detailed view of the bigger picture. I think the analytical process applied during the modeling stage of this project could be adapted to fit a lot of different kinds of structured data sets that we see in archives today. So yeah, I hope you found this interesting. Thank you.